Hi everyone, here is a quick tutorial and review of how to use the concept of molar mass to solve different types of chemistry problems. I am specifically referring to the Unit 5 worksheet number 1 that you received in class today, which is assigned for homework for whenever I see you next. So the question reads, an old pre-1987 penny is nearly pure copper. If such a penny has a mass of 3.3 grams, how many moles of copper atoms would be in one penny? All right, so to approach a problem like this, you do it the same way that you approached the other problems that were not related to chemistry. So you always want to start with the given information. So as I'm reading the question, I know that in the problem, I'm given that we are starting out with a mass of 3.3 grams. And that is describing the mass of copper that we are given at the very start. And you are asked to find the number of moles of copper atoms, so moles of copper in that sample of copper. So in 3.3 grams of copper, how many moles of particles do we have? So to set up this problem, I'm going to use the factor label method. And so my given is 3.3 grams of copper. Here I am setting up my grid. And so the first step involves recognizing where you are and where we're going. So in the end, I want to end up with moles of copper. Okay, so right here, I need to set up with some kind of conversion factor that takes me from grams all the way to moles. So the conversion factor that I will be using right now is the concept of molar mass, which is a concept that we started to develop in class today. Okay, so what is molar mass? Molar mass is basically the mass of 1 mole of a substance. So mass of 1 mole of a substance. This is a pretty generic definition, but since we know what we're dealing with, we are dealing with copper. Molar mass of copper is basically going to be the mass of 1 mole of copper atoms. That information can be found on the periodic table. So in class today, you were introduced to, or rather, you had a chance to review the information given on the periodic table. So if we find copper right here, it is right there, and you can see that copper, a single copper atom, has a mass of 63.546 AMUs, where AMU refers to atomic mass unit. That is the mass of 1 single atom of copper. But because we are not dealing with single atoms, but rather trillions of atoms, the more handy value is the mass value. So copper also has a molar mass of 63.546 grams. So the molar mass is grams per mole. If I have a mole of copper atoms, collectively that will have a total mass of 63.546 grams. So basically, if I am putting this number on the scale, within that sample, I have a mole of copper atoms. And just to review, 1 mole is equivalent to 6.02 times 10 to the 23rd particles. In this case, number of atoms. All right, so with that value on the periodic table, we can go back to our problem. So the molar mass of copper we just determined is a molar mass of 63.5. I'm just going to round a little bit. Grams per 1 mole. All right. You can see how this right here is a conversion factor. I can also rewrite it by flipping it. I can also write 1 mole over 63.5 grams. All right. I'm going to specify that I am talking about a mole of copper, because every single element has a different molar mass. All right, so now I have my two conversion factors. They both mean the same thing. So now I'm going to go back to my original problem. Find the number of moles of copper in a given mass, which is 3.3 grams. So now that I have my conversion factor, the next step involves choosing the version of the conversion factor that allows me to go from grams to moles. So I want my units to cancel out, so that means I need grams on the bottom. So of the two conversion factors, the one I'll be using is this one right there. So 63.5 grams on the bottom, 1 mole of copper on the top. At this point, you can see how the units nicely cancel out. I'm left with moles, which is what I want to find. So at this point, I can plug this into my calculator. So 3.3 grams times 1, no surprise, gives me 3.3. And I divide by the bottom number, which is 63.5. And that gives me a value of 0.0519, etc. I'm going to round that to 2 significant figures. So that gives me about 0.052 moles of copper. All right, so here you can see how I am using the factor label method, which is an approach that you've been practicing, and applying it to a chemistry problem to convert between something that we can comprehend, which is on the mass scale, to the mole scale, which describes number of particles. All right, so certainly I can actually take this to the next step and say, well, how many particles am I really dealing with? Right, and if I'm interested in doing that, I can use my second conversion factor of Avogadro's number to get to the actual number of particles, which is going to be a very large number, which is why it's a lot more convenient to use the mole, because it's easier to talk about moles than to talk about a specific number of particles. All right, so the answer to question number 1 on Unit 5, worksheet number 1 is 0.052 moles of copper. Okay, before I end, I wanted to just quickly review scientific notation. So let's say you wanted to express this final answer as a scientific notation number. The way to do that is to turn this number into a number between 1 and 10. So in this case, my number is going to be 5.2, and I set it up by doing times 10 to the some power. To figure out what that exponent is going to be, I put my decimal point right there and count. So I am basically moving the decimal point over by 2 steps. So another way of saying this is 5.2 times 10 to the negative 2, since I'm moving the decimal point to the left. So I am making the number smaller this way. So another way of expressing this is 5.2 times 10 to the negative 2 moles of copper. Either way, the number means the same thing. 0.052 moles is the same thing as saying 5.2 times 10 to the negative 2 moles of copper. And there you have it. So that is how you use molar mass with the factor label method to solve question number 1 on worksheet number 1.